All right. Perfect. So, hi everyone. Second session for today. Super excited about this. You know, one blockchain is good, but of course there's tons of blockchains, and there's one project basically doing the hard work to make sure that everything can work together smoothly. And Evgeny here from Wormhole, he's a DevRel and integration guy. And one of our besties, of course, and super team member and all this great stuff. And I'm super happy and stoked for this session and grateful that you decided and we are open to do this. It's going to be live code session, so heads up, there will be a QR code that you can scan and then you can code with him along and even deploy something in the end. So if you want to deploy your first contract program on Solana, please go ahead. And yeah, thank you so much. Enjoy. Bye.
Thank you too. Hi guys. Does it work without the mic? I start with the mic and then once we get into code, I'll just talk about louder. Yeah, so my plan for today is to basically give you guys an overview of how to deploy tokens with cross-chain capabilities. So we're going to deploy tokens to Solana, we're going to deploy tokens to Ethereum, sorry for saying. And after that, we're going to use our Wormhole native token transfer framework to basically cross-register them and then have a token which can be sent between multiple blockchains very easily. Before going into code, I just want to give you a quick explanation. What's the state of interoperability? Why would you care? Why does it matter? Just a couple of minutes before we start deploying contracts. So today, cross-chain messaging operates at scale. I think this is better. So we have at Wormhole about 1 billion messages that we processed already. 42 billion total volume was transferred by using Wormhole. Let's see where I stand so I can. Does that work? I think so. So yeah, cross-chain messaging operates at scale. It is more secure and pretty secure as in comparison to the past. We have about 60 audits across top interoperability protocols that have been made. Everything is getting audited as much as possible to ensure higher standards for security. It's everywhere. Cross-chain messaging is across all kinds of different applications. You have NFTs, oracles, swaps, token transfer, borrow lending. There's almost no application that couldn't go cross-chain by using Wormhole technology today. And one of those applications that I want to look into today is the native token transfers framework from Wormhole, which enables us to basically go and deploy cross-chain tokens natively. Why is it exciting? It is an open framework for like seamlessly doing token transfers. The exciting part about it is that you retain token ownership. So there is no wrapped tokens. The user itself, the developer, retains full control over upgradability and customizability. You can use it without Wormhole itself. It's just, as I said, a framework proposal on how to do that. Should I move somewhere?
No, you just went out of the picture itself.
Oh, so, because if I stand too close, that's fine? All right. And so two of the ways that we propose how to use this framework are a burn and mint or a hub and spoke model. So you do not need to use these two models to use the framework itself, but these are just two ways that we propose for our users to use this framework. So the burn and mint model basically enables you to burn tokens on one chain and mint them on the other chain. And the hub and spoke model would enable developers to have a hub chain. So let's say we have Solana as a hub chain and then multiple spoke chains or just one spoke chain. So on the hub chain, tokens will be locked if you prefer that, and you have a canonical balance of all of the token amount on the hub chain, and then if you bridge the tokens, they would be either minted or then burned on one or more spoke chains. We're going to do a burn and mint model example later on, so we're going to look into that more just in a second. Yeah, just to mention a bit more about security, which is baked into the framework by design. We have on-chain rate limiting. So on the protocol level, rate limits are enforced. Users can set the rate limits to go from one chain to another chain the way they would prefer it. And what another security feature is the global accountant. So that's basically a mechanism which is enforced by the wormhole guardians to make sure that not more tokens would go in the chain than going out of the chain, just to be sure that we have even more security measures in place. As I said, it's very flexible, so you do not have any kind of lock-in. Even if you would not use wormhole verification, you could still use the native token transfer framework with other attestation platforms, for example, Axelar. We basically going to do the Lido deployment soon together with Axelar. So they will go, the threshold for attestation is going to be set to more than one. So it's not only wormhole is going to verify all the messages, but Axelar as well. So you have even more security, which is independent from wormhole itself, to basically transfer tokens between chains in a very secure way. That's basically it for the short overview. Let's jump into the code and try to deploy contracts to Solana and Sequoia on Ethereum. Is it okay if I speak like that? Is it loud enough? Yeah? Cool. All right. Here's the QR code that you guys can scan just so we would have like access to the same rise up. So just basically a notepad where you can share very easily links or documentation. So that's the QR code if you would like to scan that. Yeah, it works. It works. It works. All right. Everyone good to go? Oops, wrong way. Yeah, let's go. Okay, cool. So you should see this right now. So if I write something, you should be able to see that as well and to click on documentation, for example. My goal today is to basically only use commands that we have either in our documentation or in the repository. So you guys even later on can follow along as easy as possible, even without the video, even without me explaining anything. So it's kind of a test for ourselves at Wormhole as well to see how much we can achieve just by executing commands from the documentation or the example repositories. Basically, you will see I shared 3 links, which is the documentation to all of Wormhole products, and then 2 of the example repositories that we're going to use today after deploying the tokens. One is Connect, which is a React widget, which makes it very easy to deploy a UI in just a couple lines of code. And the second one is going to be the TypeScript SDK, which is more flexible and would enable you to basically use anything you want from Wormhole products with TypeScript. I see docs are also excited about it. That's awesome. All right, let's get into it. So if we start to look at the documentation itself, how to basically start off is by installing our CLI to make it way easier to interact with the native token transfer framework. You would not need to do that. Everything is open source. You can also use our contracts directly, but we created an NTT, which stands for Native Token Transfer CLI, just to make it even easier to basically deploy the entity managers, which is going to take care of doing the actual transfer between the chains. Let's get into the terminal. So if you guys copy the NTT CLI, you will need to have Foundry and Bun installed, which are frameworks Foundry is used to make it very easy to deploy contracts to Ethereum. I'm sorry. And yeah, so if you guys will go and install Foundry, install Bun, and install the CLI, then the NTT version should, you could then install NTT CLI and it will work, and you could see the version out of the box. So if you go and check, for example, the first version, it will show you that. So are you guys installing? Is it, should we wait a second? While you guys install, I'm gonna already start and tell you what we're gonna do after having the dependencies installed. We're gonna very quickly install, we're gonna deploy a token to, an EVM token to Sequoia, which is the testnet on Ethereum. So you guys learn how to very easily transfer tokens from Sequoia to Solana. For that, inside our documentation, we have a section called Deploy to EVM. So you could then inside our documentation go ahead and see that we have an example NTT token repository already created for you, which we will then use to create a new token and deploy it to Ethereum. I'm going to wait a second. How are we doing? Anyone download the CLI? Yeah? Awesome, cool. All right, let's go ahead and then deploy a new token to Solana. Nice, docs are exciting. Let's create a new folder and just call it EVM token. So inside the deploy to EVM section, you'll find that we have an example NTT token repository, which we will use to deploy the token to EVM. So there's two functions that are needed to use the burn and mint model with our framework, which are burn and mint, as the name said. And we just created this repository to already help you guys deploy easier a basic ERC20 token with those two methods, which are burn and mint. So if we go ahead and just clone this repository, whoops, let's do it in the EVM token directory. Let's make it bigger, more bigger. Is that big enough? Yeah, cool, thanks. All right, so if we now look, we have the example NTT token directory that we can just check out in VS Code. So if you look into the source directory, you'll find that we have examples for the base token and hub token or a peer token. The base token is just an interface that we're using for the hub token. The hub token is for the other model that I described recently, because we had this burn and mint and hub and spoke model. We're going to do a burn and mint example today. So first, let's install the dependencies with Forge. Did you guys, can I go ahead and continue? Yeah, okay. So if we now do Forge build, this will install the dependencies that we need to deploy the EVM token. While we're installing the dependencies, the next thing that we're going to do is to actually deploy burn token to Sequoia. For that, we can use Forge as well. You would need to set a private key as an environment variable to use to pay for gas fees. That you can find that in, for example, your MetaMask. And then you would need the Sequoia RPC URL, but we can just use the standard one. So if we then go ahead and deploy the token with force create. So all we need to do is to basically like specify a URL. So I can send you the general RPC. That's the public one. I mean, if you want, you can use your dedicated RPC endpoints from, let's say, Alchemy. But I'm just going to share the public one that we're going to use for this example today. All right. Then you need to set a private key. And what we're going to do is we're going to deploy the, we call it peer token, but essentially we're going to use it for the burn model. But you can also use it for as a spoke. That's why we call it the peer token, because it can be used for the burn and mint model as a burn token, and for the hub and spoke model as the spoke token. Let's rename it. Let's call the token Super DE token. So SDT. And then you just need to specify the wallet that is going to receive it. We can also look into what we actually need to do in the constructor itself. So if you are in the peer token directory, you'll see that in the constructor, we need to specify a name, a symbol, a minter, and an owner. The minter and owner can be the same of the token. So this just can be your wallet if you want to make it easier. So let's go ahead and deploy a token to Sequoia. Let's see if we can deploy stuff today or not. All right, that worked. So we now deploy the token to Sequoia. We can check it out on Sequoia Scan, for example. Sequoia is the testnet for Ethereum. All right, that worked. Cool. So what we want to do next is to mint some tokens that we can, because we want to have a balance. Otherwise, we won't be able to transfer tokens over to Solana. So if we look into the docs, we're going to see, if you look here into the repository, we're going to see that we can also use Forge to actually mint the tokens after doing the deployment. So let's copy that command and just adjust a few values. So we need the token address of the new token, which is this one here. We will need the recipient address, which is our wallet that we used. We'll need an amount in Wei. So we want 1,000 tokens. That will be, because it has 18 decimals, there will be this number here that I can also share in our chat, our Rise Up. So we want to have 1,000 of the Super DE token. We want to use our private key. Why is he complaining? And we want to use the RPC URL that we used before, just the public one. All right, TCP connect, probably, let's see what went wrong. Cast, send, probably some formatting. 1 second, let's see. We're going to use the private key that we have. Oops, sorry, I forgot the key. So the flag is private key. set a private key. Okay. Something is. Let's see. Let's check it out. Maybe we kind of copied the wrong cast command. That's classic. Always it works 5 times before the presentation. In the presentation, we have an issue. Okay, let's do it again. Let me copy the command from where I tried it before. Probably something about formatting. All right. We don't want it on base, but we want it on Sequoia. The same wallet, and we just need to adjust the token address. Let's see if that worked. Oops. All right, that worked. So probably we had some issues with the formatting inside the terminal before. So what we did right now is to deploy tokens to Sequoia and now mint them as well. So we should, if we check our wallet in Sequoia scan, we should have 1,000 of the super tokens on Sequoia now, the super DE tokens. So if I go ahead and check my wallet, let's see. We will find the, how did we call it? SDT. So there you go. We have 1,000 SDT tokens. So next step will be to deploy to Solana. So for that, we will need to have Rust, Solana, and Anchor. We can either deploy an SPL token or a token 2022. We will just today, to speed things up, deploy an SPL token. We do it completely from scratch. So we're creating a wallet and then deploying the tokens to it. Let's close the EVM example. We don't need it at the moment anymore. Let's go back to the terminal. Create a new directory for the Sol token, and then just follow along the steps that we have inside the docs, the wormhole docs. So first we're going to create a new wallet to basically do it completely from scratch. Then we're going to set the new wallet. What we're using, sorry, I should have mentioned that we're using the Solana CLI. So inside the Solana CLI, we're now going to set the newly created wallet as the wallet that we want to use for deployments. We can do that with the config set key pair command. 1 second, let's not do the relative, but the absolute path. So if we do a PVD, can now do Solana config set and set the key pair to the just newly created one. So now, as a next step, we will go ahead and set our used network to DevNet and airdrop us some funds. So let's copy the command. Now it's on DevNet. It was before as well, but I just wanted to show you that. Now we're going to airdrop us 5 Solana on DevNet. Another possibility, if you need more Solana DevNet funds, is you can use faucet.solana.com. To then get even more funds if needed. So if we do Solana balance and Solana config get, they will show us we have 5 Sol on this public key, which we use as our wallet. So if we put it in here and request 5 more, then we can get 5 more Sol, just to be ready in theory. But Cloudflare doesn't like us today. Let's retry. We are human. Okay. Second try. Accepted that we are human. That's cool. So let's see if we have 10 Sol now. All right. So we're ready to go and to deploy some tokens to Solana. Let's continue following our documentation. So now we install the SPL token CLI, and then we're going to go and create a token. Yeah, someone has questions? I tried to be a little bit faster in the beginning just to speed up the EVM process. But now on Solana, if you guys have any questions, feel free to always ask. So far, so good?
Yeah, awesome. With using other chains, what are some considerations to put in place? Is there any like if I wanted to say move onto Chain, for example, what would be the biggest configuration differences that I'd be looking at? Is it all the same configuration, basically just changing the?
So if it's a chain, so for right now, NetNTT, the way for wormhole attestation, it supports only EVM chains and Solana chains, and SVM chains. So if you want to deploy, I mean, Bera is not even live yet, but if you want to use Move, you would need be a bit more involved. But we're working on a Move implementation at the moment, but it just needs some time because we need to get audited and stuff like that. But you can still use other products, or you can directly interact with our contracts. You could not just easily use our CLI for that. All right, so then let's go ahead and continue with deploying the Solana tokens. So we now created a token. Now we're going to create an account for that newly created token. And next up, we're going to mint as well 1,000 tokens to ourselves. So we need the address from the token that we just created by using the SPL token CLI again. Oops, sorry. We need this token, and we want, let's say, 1,002 tokens. So that was faster, I guess, on Solana. So what we did so far is basically deploy the token to Sequoia, which is the Ethereum testnet, and minted tokens to ourselves, and do the same on Solana. We deployed tokens and minted them. So as a next step is what we want to do is to actually use the wormhole entity CLI to deploy the entity managers, the transceivers for verification, and to then actually perform the transfer of tokens from chain A to chain B. For that, on the Solana side, what we need to do is to create the entity project itself first. So you can see from the docs how to do that as well. So if you want to deploy entity, you would go ahead and again create a new project. Let's call it Super Team DE token. So now is the actual cross-chain wormhole part. The previous was kind of the prerequisites to have two newly deployed tokens on both chains. So if we now go ahead and look into this newly created directory, we can then specify that we want to use testnet for that. So we're initializing testnet configurations, and the most important file that we're going to look at is the deployment.json file. Let's make it bigger. So right now, if you look at it, it just says testnet. But what we're going to do next is to basically set the tokens for the different chains and specify which tokens we want to have to then cross-register them with each other to perform the transfer afterwards. So we're going to, if we add new chains by using our CLI commands, we will you will see that this deployment.json will have more configuration. So we're going to set which tokens we want to use, rate limits for the tokens itself, and then push that on chain and then perform the transfer. So now it's empty, but just like give you a heads up what's going to happen next. All right, so after this, we need to do a few more steps on the Solana side. So first, we need to generate an entity program key pair. Let's do that in the newly directory. Okay, let's call it just NT. All right. Now we need to derive the token authority PDA of the newly generated entity program ID. And now we can set the SPL token mint authority to the newly generated token authority PDA. These are just a couple more steps that are needed on Solana, sorry, to then go ahead and deploy in burning mode. So after doing this, we need to take this command, take our previous token address that we created. Where was the token? Okay, I should have saved the token address. 1 second, I'm gonna check out the token address that we created before in the other directory. So if we go back to the sol token directory, let's just, what we can do is just check based on the wallet that we just created, what the new token is that we just deployed. So if you go to the Solana Explorer, for example, and check on DevNet what happened with our wallet, we should see a token address. All right. So if we check SPL token balance of this would show us 1,002. All right. So this is the token address of the token that we just created, or like that I just created. It will look differently on your machine. So if we now go ahead and continue the documentation tutorial, we can set the SPL token mint authority to the newly generated token authority PDA, as I mentioned. So for that, we need the token address and the derived PDA. That was from the previous step. All right, and now we're basically ready to go ahead and to deploy entity on Solana. We can do that by executing this command. So we're using the entity CLI and saying we want to add a chain to our configuration, which is Solana. We want to use the latest contracts. We can specify the mode. As I mentioned before, we had this. Let's make this bigger. It was possible to either have the burn and mint model or the hub and spoke model. So here is where we're going to actually specify which of those two models we want to use for this deployment. So it's going to be burn, and then we just need to specify the SPL token that we used, that we just created. You don't need to create it from scratch. I just wanted to do it today to show you how that will work from scratch. And then we need to specify a payer who's going to pay for the gas fees. It's going to be the newly created wallet. And then we need to specify the program key that we also just created ourselves. Program key. And where do we have it? We have it in the super team DE directory. All right, so we need to actually go ahead and change directory to the super team directory, because this is where we have our deployment.json, so the configuration file. And in there, we're going to execute the entity add chain command. And there we have the newly generated program key as well. So what we're doing right now is to deploying entity on the Solana side. Oops, I have the wrong CLI version. So let me just change that. Anchor, what was the command again? I think it was AVM use 0.29. So we need 0.29 anchor version right now to use with the CLI. All right. So we're going to do the same on the EVM side as well to deploy, to add the chain configurations that we want to use with NTT as kind of the final step to then push this on chain, to then have both contracts on Sequoia and Solana cross-register with each other, the entity managers deployed, and the transceivers that are going to take care for the verification also deployed, to then actually perform the transfer between those two tokens. What's happening right now is that we're compiling and building, and then ideally, if the deployment works, we will see a difference in the deployment.json file, which is our main configuration file that we are using for the NTT deployment. Any questions in the meantime? Please.
But, so when you talk about like deploying with the hub and spoke model,
Mm-hmm.
can you maybe like, I don't think I'm like 100% clear on it, maybe you can go into a little more detail so I can better understand. So basically, in this case, there's like a core contract that's kind of governing the token, and when you want to deploy onto the other chain, it's kind of like is it like a holding zone? Basically, that's defined.
So for the hub and spoke model, the difference is that instead of burning the token on, let's say, Solana and then minting them on Ethereum, you would then lock the tokens on your hub chain inside the contract. Yes. So the manager itself would make sure that your tokens are locked, and then you will have basically one canonical balance of all the tokens across all chains just on your hub chain, if you want that. That's just that's optional. And then if you have the tokens on your spoke chain, they will get then minted with the transfer or burned when transferred back on your hub chain. Does that answer the question, kind of?
That's kind of how, like, for example, like the Cosmos to EVM, like they have like gravity bridge. That's kind of how that one works, right?
I'm not familiar with the gravity bridge. Sorry, I don't know. Yeah. But happy to give you more details later on as well. So what we did right now is to do to change the configuration and add the chain to our deployment.json on the Solana side. So if you now look into our configuration file again, we now see that we have a lot more information in there. We have the specified testnet, we have the mode, the burning mode. We have our token manager specified, the token that we just deployed, and the limits that we're gonna just also modify in a second. So what we need right now is a second chain, because transferring to a second chain is what we want. So let's go ahead and execute the same command, or like the similar command on the EVM side. So what we're gonna do here, just again looking at our docs, checking how to deploy to EVM, and then executing, using the CLI again to deploy to Sequoia. This time we need just the token address itself. Again, so we're specifying that we want to deploy to Sequoia. We want the latest contracts. We want burning mode and the newly token that we just deployed to Sequoia before, the token address that we need to adjust. Let me just check how. I again forgot to write down the address of the token that we just deployed together, but we can definitely find that out by checking our wallet on Sequoia scan. I believe I had this wallet right here. No, it was not this. 1 second, sorry. Just need to find out the token address of the newly deployed Sequoia token. What would be the easiest way? It was the super team DE. Sorry, 1 second. Just trying to find out the token address of the previously deployed Sequoia token that I didn't write down. Should be one of the commands that we just used. There you go. This is the cast command that we used to deploy, to basically mint tokens on Sequoia, and there we specified the token address. So this should be the token address that we need for the command of the entity CLI. So now we're doing the same that we did for Solana on Ethereum to specify which token we want to use for our configuration. Any other questions in the meantime? So you're running a bit out of time, but we're almost done with the entity deployment itself. What we're going to do next is just adjust the rate limits between the chains and actually push the contracts on chain. And afterwards, I would like to very quickly show you guys how to use our Connect, basically Wormhole Correct React widget to make it very easy to create the UI and actually transfer the tokens between those two chains. Yeah, this is going to take just a couple of minutes. Let's see the deployment on Sequoia. Seems to work. So we're deploying Wormhole entity on Sequoia right now. All right, that worked. Cool. So if we now look again at our main configuration file, we now have two chains in there. We have Solana, we have Sequoia, both in burning mode with the specified addresses for the owner, the entity manager, the token itself, and the transceivers, which are used for verification as well. So what we want to do now is we have some helper functions of the CLI that was going to basically tell us as well what to do. So if we do entity status, it's going to tell us, all right, you need to either do entity pull or entity push because our local configuration looks different than from the configuration on chain. So we're going to entity pull first to see what kind of rate limits currently we have on chain. So if you look at our deployment.json, we currently have, for example, an inbound limit from Sequoia to Solana of 0. So if we would not modify this, then no transfers would go through because of the rate limits that we didn't modify so far. So let's go ahead and modify the rate limits for inbound and outbound transactions. Let's do that in VS Code. Let's just set it to 1,000. So that means that 1,000 tokens maximum could move between, for example, here from Sequoia of this token to Solana. And what we do now what we want to do now as a final step is to basically push this like on chain. So we push all the contracts on chain and the new rate limits that we have to then finally execute the transfer between those two chains. For that, we also need to specify a pair on Solana. We're going to use our wallet. Whoops, sorry. Let's check the balance. If we have enough, yes, that should be more than enough to push these configurations on chain. So that's the final step of pushing like everything on chain. Now we have what we did so far in the last 45 minutes is to deploy a token to Solana, mint some tokens on Solana, do the same for Sequoia, deploy the contract, mint some tokens. Then we deployed the entity managers for both chains. We configured the rate limits for inbound and outbound rate limits on chain. And there will be, in theory, all that is needed for in order to use any kind of cross-chain transfers or to send messages, arbitrary messages between those two configured chains with the specified rate limits. But what I want to show you in the last like 10 to 15 minutes is to how actually do this to send it, to actually transfer tokens between those two chains. Whoops. So if we now check entity status, it should tell us that everything is fine. We deployed all the contracts on chain. We set up our rate limits. So it says that, yes, our local deployment on JSON, which is our configuration file, is up to date with the on-chain configuration. So if we now go ahead and use basically the connect example. Connect is our React widget. We will be able to very easily execute a transfer between those two chains. So let's just, inside the RiseUp is the connect example on GitHub, if you would want to use that. So let's clone it into our repository. And then what we can do is follow along with the README itself. So we would then first install the dependencies. If you look at the package.json, the main dependency that I want to point out is the Wormhole Connect SDK, besides React, that we're going to use to create a UI as easy as possible. So let's wait a second for the dependencies. And what we're going to do next after the dependencies are loaded is to actually adjust the Wormhole Connect config. So the basic configuration file that we need to specify the tokens that we just used. So let's look together at the code. If we go into the source folder, so here is the Wormhole Connect config. So in here you can specify basically the networks that you want to use. We want to use Sequoia and Solana. You can specify the names of your tokens, and then you have some configurations that are needed in order to perform the native token transfer itself, which is the entity groups and the entity managers. But all this information is retrievable very easily from the config file of the deployment itself. So if we go ahead and look at our deployment.json again, we'll find all the information that we need. We find our manager address, the token address, the transceiver addresses to actually perform the transfer. So what we need to do here is to look at we have it as comments there as well. So the entity manager for Sequoia, we can just copy it from the deployment.json file again. So we need the manager to go in here. We need the transceiver address. Again, we're just copying it from the configuration file. Sorry, that was Solana, but I need Sequoia. So let's go here. The Sequoia manager goes to the Sequoia manager in Connect. The transceiver address. Now we need the same for Solana. the manager address, and the transceiver address. Transceiver is again just another name for verifier, like exactly like to verify and to attest all the messages. All right. The last thing that we need to change is the token address, which we will also find in our deployment.json configuration file. So the token on Solana and the token on Sequoia token goes in here. And then we're basically good to go. This is just a very minimal example. I just want to show you how easy it will be to spin up a UI and to actually perform the transfer. So if we now do npm run dev inside this cloned repository, we'll be able to, in theory, see the UI. So out of the box, we have wallet connection integrated. So now we see we specified ourselves that we want to have the Sequoia network and Solana. We can connect our wallets, like Soulflare, Phantom, whichever we want. And we will be able to transfer tokens from one chain to the other. I don't have the newly deployed tokens on this wallet, so let me go ahead and change the browser. I believe I have it on Chrome. Yeah, we would need to if you want to actually use this UI right now, we would need to connect the wallet where we have the tokens with basically import the wallet to Phantom or to Soulflare or whatever we want. What we can do, because I don't want to import it just for the sake of time, what we can do is to basically see that we have the possibility to transfer tokens. Let me actually go ahead and connect my Soulflare wallet and send some tokens to the Soulflare wallet. Solana transfer. Actually, it's just 5 more minutes. So what I want to show you is to basically how easy it was within just a couple of minutes to specify the network, to specify the assets, and then this is an example of a different token that I just created yesterday, the FTT token, to then basically execute the transfer. So after doing the deployments and the minting and cross-registering everything, this way we will be able to use Connect to just modify a few addresses that we can get from our deployment.json configuration file, and then basically go ahead and transfer them. And the last thing that I want to just emphasize, for the sake of time, it's just 5 more minutes, we won't be able to look into the TypeScript SDK. But what would be needed, if you, let's say, if you want more flexibility, if you don't want the UI to if you don't want a UI in general, but just want to basically transfer tokens from chain A to chain B, or use any other of our products, then you can go ahead and use our TypeScript SDK. For that, I linked a TypeScript demo repository as well in our Rise Up. So you could go ahead and clone it and then also follow along the README to basically see how to do the transfer, not from the UI, but from a TypeScript example. All needed for that would just be to modify the constants that you have here as well mentioned in the README, and then you could go ahead and execute an entity transfer by using the TypeScript SDK as well, and not from the UI. but I'll leave it there just for the sake of time. It's 4 more minutes. Any questions? Let me. Otherwise, I'm gonna also send here my. So I have the same name on Telegram, Discord, or X. It's always Evgeny DeFi. So if you have any kind of questions, please feel free to always reach out. And yeah, thank you so much for listening.
Cool. I hope we all learned today. At least I did for my part. Thank you so much for doing this. Really much appreciated. We have a 5 minutes leg stretch, and then we continue with Keith and Orion. Thank you.